For more information, please visit SGMAK Associates website.
Hi, in this module, I'm going to discuss equivalence between net present value and internal rate of return approach to solving a problem, and also another important concept, which is the break-even analysis. So let me walk you through a few examples to convey these concepts. First problem is, as an example of break-even analysis, we got two alternatives. Cost data are given. You got initial cost. You got uniform annual benefit for each alternative. Alternative A has infinite useful life, something what you say runs forever. Alternative B has a finite life, unknown finite life. You want to find out for what value of the unknown finite life alternative A and B, they are equivalent. A breaks even with B. We solve in terms of net present value. So net present value of alternative A is net present value of benefits minus the net present value of cost, which comes out to be $250. $75 of uniform annual benefit for infinite cash flow converts to a present value of 75 divided by the interest rate, which is 10%, 0.1, and that gives you $750 annual benefit. So net present value of alternative A is $250. Net present value of B is present value of all cash flow over X years minus $300, which is a function of life of useful life for B. When you equate net present value of A equals net present value of B, when we solve for X, we find X as 14 years. So at 14 years of useful life for B, it breaks even with A. That's the point of indifference for X equal 14. And beyond that, or less than that, you have a clear choice, one over the other. So that's an example of break-even analysis. Now let's look at next example. You want to find the future worth of a cash flow. So you have a monthly deposit of $200 in an investment that's earning 9% annual percentage rate at compounded monthly. So you got 12 compounding period a year. You make deposit for first 24 months and then you let it grow. Don't make any payment after that. Let it grow for 5 more years. And then you want to withdraw the money at the end of 7 years. You want to find out what's the value of the portfolio. What is the future value of the portfolio at the end of 7 years? So this is estimating a future value of a cash flow. So interest rate here is 0.75% per month. You got 12-month compounding period in a year. So 0.75% per month. So the future value is 200 times. First you have a factor F over A, 3/4 and 24. What that does, it takes $200 annuity cash flow and converts into a future value at the end of 24 time periods, which is end of 7 years, because you made 24 deposit end of each month. And then you multiply that by a factor F over P, 3/4 60. So what you're doing now, you're taking that future value end of 24 months to 60 time periods ahead in future and finding the future value. So you got two different factors, you got to pay attention to those. First one is F over A, converts annuity to future value at the end of 24 time periods. Second one is F over P, converts a single cash flow end of 24 time periods to end of 84 time periods. Now you just use the table lookup values, you put them into the equation, and this this plan gives you a future value of $8,202.70. So important thing is to pay attention to how those two factors come into play as you move the cash flow first to end of 24 time period and then to end of 84 time period. Now next you want to show the equivalence between net present value and internal rate of return. Let's look at the example here. You have initial cost of $250,000 and has useful life of 30 years, annual revenue of $20,000, and annual cost of $6,000. So we want to find out the internal rate of return. So all that we do, we set up the net present value for this project. I set that equal to 0 to solve for the unknown interest rate, and you get a value of 3.73%. So internal rate of return is between 3.5 and 4%. So decision rule based on internal rate of return. If your internal rate of return is more than your minimum attractive rate of return, you accept the project. If it is less, you reject the project. And of course, you're indifferent, they happen to be equal. MARR stands for minimum attractive rate of return. So if you have a borrowing rate of 4%, if that happens to be our MARR at 4%, my net present value comes out to be negative. So a project with a negative net present value means you are not recovering the cost. So you're losing money on that project, so we reject that project if net present value is less than 0. At 4%, we also reject the project based on IRR because my IRR is 3.73%, which is less than my MARR. So you can see that both net present value and IRR gives you the same results at MARR at 4%. If you take MARR at 3%, you lower the rate. Now you have a net present value positive $24,000 and $24,460. Since the net present value is greater than 0, we accept the project. And as you can see, your IRR is 3.73%, which is greater than MARR at 3%. So you accept the project based on the IRR decision also, IRR rule also. So you can see an equivalence between net present value and IRR approach in case of simple investment. Simple investment, you have a cash outflow followed by net cash inflow of the project. So this example through numbers shows the equivalence between net present value and IRR approach to solving a problem for simple investment, and we have defined that. Same thing, I've set up a simple symbolic equations here just to show the same thing what you just showed numerically in the previous example, that in solving net present value we set up solving the IRR, we set up net present value equals 0 to solve the interest rate for IRR. And so if you look at this two equation, it's difficult to explain without using numbers, but this brings out just the previous examples that we did with numbers, that if your rate of return, if your net present value is positive, then your IRR is also greater than your minimum attractive rate. So through this simple exercise, which comes out a lot clearer through numerical analysis. So again, to conclude, If you have a simple investment problem, you can solve either with net present value given your MARR, or you can solve with IRR and then compare that with MARR and take a decision. And both will give you the same decision. Hopefully this will be of use to you. Thank you. Bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.